Good afternoon, sir. I'm Arshia from Computer Science Department. Today I'm here to give a seminar about homogeneous recurrence relations. Homogeneous recurrence relations. So the outline of this seminar is recurrence relation, order of recurrence relation, linear recurrence relation, Fibonacci recurrence relation, methods to solve recurrence relation, example problem, and conclusion. Recurrence relation. A recurrence relation for the sequences of set of a comma n is the equation that expresses a of n in terms of one or more of the previous terms a0 comma a1 comma a2 comma up to so on a n minus 1 for all integers n with n greater than or equals to n naught. Some examples about this. If an denotes the nth term of the geometric progression with common ratio r, then an is equals to r dot an minus 1. Example 2. If d is a real number, then the nth term of the arithmetic progression with common difference is an is equals to d plus a of n minus 1. Order of recurrence relation. So let us know the order for the recurrence relation. The order of recurrence relation is the difference between the largest and smallest subscript appearing in the relation. So the difference between the largest and smallest subscript is known as the order of recurrence relation. Example: a of n plus 3 of a n minus 1 is equals to 0. So here the order is here the largest uh, subscript is n minus so we have to do the difference, so n minus smallest is n minus 1, so n minus of n minus 1 leads to n minus n minus n plus 1, so the order is 1. Here the same thing, a of n minus 2 a of n minus 1 plus 3 of a of n minus 2. Here the largest subscript is n and the smallest subscript is n minus 2. So n minus of n minus 2, which leads the order to 2. Note, recurrence relation is also called as a difference equation. Linear recurrence relation. Suppose n and k are non-negative integers. A relation of the form c0 of n a subscript of n, c1 of n a subscript of n minus 1 plus c2 of n a of n minus 2 plus 2 up to so on c kth term of a. So it comes like a of n minus k is equals to f of n. Concluding this as an equation 1 for n is equals to, for n greater than or equals to k, where k naught of n, k naught of 1 comma n up to so on c subscript of k of n and f of n are functions of n or constants is said to be a linear recurrence relation. If f of n is equals to 0, then the relation is said to be homogeneous linear recurrence relation. If f of n is not equals to 0, then the relation is said to be non-homogeneous, also known as inhomogeneous linear recurrence relation. If c0 of n, c1 of n, up to so on ck of n are constants, then the relation is said to be a linear recurrence relation with constant coefficients. Fibonacci recurrence relation. The recurrence relation f of n is equals to f of n minus 1 plus f of n minus 2, where n is less greater than or equals to 2. With initial condition f of f naught is equals to f1 is equals to 1 is known as Fibonacci recurrence relation. Methods to solve recurrence. So here are some methods to solve recurrence relation. There are mainly three methods to solve recurrence relation: substitution method, generating function method, characteristics root method. So let us know about substitution method, which is also known as iteration method. In this method, the recurrence relation for a of n is used repeatedly to solve for a general expression for a of n in terms of n. Note, this expression don't contain any other terms relation of the sequence except those given by initial condition. Example problem. Solve the recurrence relation for a of n plus 1 is equals to 5 of a of n, 5 into a of n for n greater than or equals to 0, given that a naught is equals to 2. So given, first we have to write what's the given in the problem. So given a of n plus 1 is equals to 5 of a of n, uh, note it as equation number 1. So they gave a condition where n is greater than or equals to 0 and also a naught is equals to 2. Substitute, we have to substitute n is equals to 0 in equation 1. Substituting n is equals to 0, we'll get a of 0 plus 1 is equals to 5a of 0. So here it means a of 1 is equals to 5 a naught. In this we have a naught is equals to 2. So a1 is equals to 5 into 2. Substitute n is equals to 1 in equation 1, where a of n plus 1, substituting n is equals to 1, a of 2 is equals to 5 into a1, where we have a1 is equals to 5 dot 5 into 2, which means 5 square into 2. Substituting n is equals to 2 in equation 1, a of 2 plus 1 is equals to 5 of a of 2. It means 5a3 is equals to 5 of a2. a2 we already have 5 square into 2. So we'll write 5 into 5 square into 2, which means 5 cube into 2. So similarly, a of n is equals to 5n into 2. Therefore, a of n is equals to 2.5n. Conclusion. Recurrence relation for a of n plus 1 is equals to 5 of a n for n greater than or equals to 0, given that a naught is equals to 2, a n is equals to 2 into 5 over n. Thank you.